Good morning, everyone. In the last session, we discussed about the one of the important implementation class called linked asset here. Okay, how this linked asset is working internally. So, basically, whatever the order we are trying to insert, the same order we are trying to get this particular information here. Getting the point. This is the one of the important we are understanding here. Getting the point. This is the one of the important information we identified here. Okay, so this is not the linked list. So this is we discussed in the last session. And however, I'm trying to insert internally the same way I'm trying to get this particular object here. Now you can see the output is showing. So this is the way of ordering the output. And along with this, if I'm going to add all method, what happens internally? For example, I'm using add all method. So here I'm going to use this particular hash set here. Get in the pen. So using this particular hash set, I'm going to initialize this particular values here. Okay. So this is important. We need to understand here. Hash set I created, and inside this particular hash set, I'm going to add some values here. Something like 357. And so 241. I'm going to add three records here. And here, what I'm doing here, I'm trying to add so 689. Okay, these are all the three records inserted into which object here has set. Getting the point. Here I'm trying to use this particular hash set here, and I inserted three records here. So after insert these three records here, now I'm going to call LHS linked hash set, and I'm going to call add all method, and here I'm going to pass hash set. Okay, I'm going to pass hash set. Now we'll see how this particular data is inserted here. How this particular data is inserted. Now you can see. So first one 357, 689, and 241. Because here what we are doing is we are trying to inserting into the hash set. Hash set internally how it is going to insert based on the hash code. So this is the order internally it is followed inside this particular hash set. But if we are so we like here we are trying to follow this particular 357 and 241689, but internally the 689 is a second record. 689 is a second record, and we inserted the 689 as a third record because we discussed in the last session how this asset internally it is going to work. How this particular asset internally it is working, we identified here. Okay, how it is working here? First is going to identify the hash code, and later it is identify the key. So based on this particular two information, now it will store in the node. Getting the point? We have a node, and this node is expecting key value. So this is the array type we already identified here. So this is we are calling as a table. So inside this particular table, now it is trying to insert it based on this particular hash code and key. Okay, so the first one is identified in the first index location, first one is equals to something like 357, and here the second record now it is updated as a 689. Okay, now the third record is updated as a 241. Getting the point? Because this is the hash code and into the key. Based on this particular hash code and key, it is our objects are modified internally inside this particular hash set. The same object we are inserting into this particular linked hash set after calling this particular add all method. Okay, so each and every method is same, the purpose is same, but focus how these objects are calling internally. So right now we don't have an option to discuss this particular. Get in the linked hash map here. we'll discuss whenever we are discussing about the map related section. Map related section. Okay. This is we can understand the how the linked hash map internally it is going to work. Okay. So try to follow the remaining information what we are discussing here. Okay, add all method we identified. Now I will check this particular contains method. So here I'm trying to pass what is an object I can pass here, something like 963. Okay, 963 I can pass. So if I'm going to check this particular contains method, so what is the value of this particular contain method will return true value because this object is already available inside this particular linked hash set. Now you can see it is returning true value. Getting the point? This is important. Now if I'm going to call the same contains all. Okay, contains all. So here what I'm trying to pass here something like HS, something like a HS, like a hash set I'm trying to pass here. This is the line number 10 we created hash set here. Now observe carefully whenever I'm trying to pass. So this is also it's returning true. So how it is implementing this particular contains all method? First, it will try to come up with the one loop. Inside the loop, we are going to call same whatever the contains method we discussed just now. Okay. So contains and contains all basically what is the purpose here? Whatever the object we provided. So this object it is available inside this object or not. Getting the point? Whatever this particular object we are checking here. So something like earlier we discussed about the 960. So this 963 it is existed inside this particular linked hash set or not. It is going to check. If it is existed, it will return true. Otherwise, it will return false. So it is the Boolean return type here. Getting the point? It is the Boolean return type. It is going to return here. This is the one of the important example we are discussing here. Now same thing contains all. So in the contains all also whatever the value we are going to pass, the values is available inside this particular linked hash set or not. It is going to check. So if it is available, what happens internally? It will return true. Okay, it will return true. Otherwise, it will return false. So the purpose is same, but only the difference is here. Contains method will pass only one object. Contains all method we are going to pass multiple object here. Okay, so this is only the changes we need to understand. And another method, what we can understand here, retain all. Okay, so this is the retain all method we are going to discuss here. And now what we need to understand what we need to understand regarding this particular retain all here, what we need to understand regarding this particular retain all. So whatever this particular object we are passing here, if these objects are available inside this particular linked hash set here, so it will keep, and remaining objects it is trying to remove from the particular linked hash set. So for example, what is a hash set object we are having, what are the hash set object we are having here? So now you can see. See, the instruction was it is in order only. Getting the pen. How we are inserting? The same way only we are getting an object here. This is something like we are following the order. But if we want to follow the ascending order or descending order, this classes is not the suitable class. So once we have completed this, we'll discuss about the tree set. Tree set is the like implementation class of the same set interface, and the tree set will give you the ascending or descending order. Okay, so the class we'll discuss later, but observe carefully this hash set records. What are the hash set records we are having? First one is something like not 963, so something like this is a 357. Okay, and 357, something like 689 and 241. These are all the HS object. And here I'm trying to create a linked hash set. So it is containing multiple objects. It contains multiple objects. So first one is 789 and linked, not linked list here. So linked hash and something like 852 and set and so 963. We are having multiple objects here. So 357 and finally what are the values we are having? So after 357 we'll try to pass as a 689 and 241. Only these three records will available. Remember, these three records are available inside this particular linked asset, and whatever I created above records, these records are going to remove from this particular linked asset. So why it is going to remove? Because internally, what we are doing is we are trying to comparing the object. So this is an asset I'm passing here, and this asset object, if it is available inside the linked asset, this object will contain linked asset here. Getting the point? This is the asset object we are having, and internally this is the linked asset object. Okay, right side one is the linked asset. Now what I'm doing is it will try to identifying whether this 357 is available or not. So here we are having the 357. So once this object is available, it will available inside this particular linked asset. So same way 689 also it is available, and 249 also it is available. Now what we need to understand here, the remaining object, those are not matched records. These objects are not going to available inside this particular linked assets. So why these objects are not available? It is because of a retain all method. Okay, right now we are calling this particular retain all method. So now observe carefully. Whenever I'm trying to execute this, now you can see only three records we are having. Only three records we are having, something like 357, 689 and 241. So whatever I explained here, these three records only available inside the linked list only. So whatever the collection I'm passing here, the collection I'm passing HS. HS is the asset. Line number 10 we are creating the HS. Okay, how many record I inserted? These three. Getting the point? These are all the three records I inserted into the asset, and the remaining I inserted into this particular linked asset here. Okay, this is we need to understand here. Only these three records are matched to this particular linked asset, and these remaining records are not matched here. Okay, the three records only matched, remaining are not matched. So the remaining records are going to remove from this particular linked asset. Okay, so we'll see the code how it is implemented. Now I'm calling this retain all method. Now if you see here, I'm calling the remove method. I'm calling the remove method. But before calling the remove, what is the method I'm calling it? Contains method. Basically contains method, what it will do? It will try to return the true or false. Okay, it will try to return the true or false. So here what I'm doing is, if this particular object, whatever object I'm passing, if this object is available inside this particular collection, getting the point? If this object is available inside this particular collection, it will return true. Okay, it will return true. But here, whenever this collection, sorry, this contains method is returning false, getting the point? This contains method return false here, then this condition will satisfy, because here we are using not condition. So not condition, basically it will work on the opposite manner. If the contains method will return true, it will convert as a false. If it is returning false, now it will convert as a true. Okay, and what we identified the contains method, if the element is already existed in the particular linked asset here, so it will return the contains method true. Okay, so contains method will return true. Getting the point? Because this records is already existed inside this particular linked asset. If this record is not available, it will return false. Whenever it is returning false, at the time this condition is satisfying. At the time this particular condition will satisfy, and it is calling internally remove method. Okay, so how many times it is going to satisfy? Only three times, because these three records only available inside this particular linked asset. Okay, These three records only available inside this particular linked asset, and these most probably 6 or 7 records we are having. These records are not available inside this particular asset. Because of this, so each record is going to remove from the linked asset. Okay, this is one of the important example, like one of the important method we are discussing, retains alls. This is very important. Only matched record will keep, and unmatched records are going to remove from the particular object here. So what is an object we are having? Linked asset here. Okay, so only these 3 records are matched here. Any questions on this retains method? This is very important. The retains all method is very important method we are discussing here.
So, sir, whenever we need to use the retains all method, so before that we need to use this contains also to check if the object is there or not.
Yeah, that is you can check. If it is available, we can call the same retain solve method, because here we are checking already internally. We don't need to check basically here. The retain solve method is checking here. But the condition what we are using, not condition. If the object is not available, then only the object is we removed here. Because contains method basically what it will happens internally, whatever the object we are passing as a parameter, the object is existed or not is going to check here. If it is existed, it will return true. If it is not existed, it will return false. So whatever the object, it is not existed. So in that case, it is returning true, because we are using not condition. So those objects are going to remove here.
Got it.
Okay. But explicitly, if you are going to check the contents, even though if you are returning true, so what happens internally? Those objects are kept, and some object, if those objects are not available inside this particular contains method, now those records are going to remove here. For example, here, where is the linked asset? And here I'm going to call contains method I'm calling. But how many objects we can pass? Only one object we can pass. So something, if I'm going to provide this particular 1, 2, 3. Now this object is not available inside this particular linked asset. Getting the point. Now you can see it is returning false. So when this particular objects are returning false, now what happening internally? Those objects are going to remove from the linked asset. So observe carefully. Here we need to understand the one more time the same method here. What we are passing? C here. So C basically what we are passing here? Asset. Now if you see here, the collection we are passing as a asset here. Okay. And so on top of this particular asset, I'm calling the contains method. Okay. On top of this particular, go to, so this is the collection I'm passing is something like here we are passing asset, HS we are passing, and here what we are calling C. C is nothing but HS dot contains. Okay, inside the HS how many records we are having? 3 records. So 357, 689, and something like a 241. Some I hope only 3 records we are having. Now what I'm doing here? So using this particular 3 records here. So using this particular 3 records, I'm trying to check the entire linked asset. Entire linked asset we are checking here. So here we are having some big records here. So something like 789 linked hash, and here we inserted one more object as I said, some remaining objects here. So between we are having these records also. So like 357, 689, and 241. These records only matched. How many records will match here? Only the last 3 records. These records are not matching. Why it is not matching here? Because we are comparing with these 3 records only. Okay, this is important. We are comparing with these 3 records into this particular linked asset. Because if you see here, whatever the iterator we are calling, this iterator it's going to call on the linked asset, not on the asset here. Getting the point. So here we are passing linked asset one by one object. First we'll pass 789. Second we'll pass this particular linked. third we are going to pass hash, and fourth we are going to pass as a set. Like he will keep on passing this. So whenever this object is matched here, so this object will keep, and these objects are not matching. When it is not matching, contains method will return false. When it is returning false, this because of this not operator, it is making as a true. Because so we discussed this particular not operator, it is going to work on the opposite behavior. If it is returns true, it will return as a false. If it is written false, it will make as a true. Okay. So in these cases, it will return as a false because so these objects are not available inside this particular hash set. So it will return false. Whenever it is written false, because of the not we are making, like this condition will return, and it will call internally remove method. Okay, the current object is going to remove. This is important. If you're trying to check any object, reference is important. What is the reference we are passing here? So here we are passing C. So inside the C we are passing as a hash set object, and on top of the hash set only we are calling the contains method. And here we are passing the linked hash set object. But whatever we are doing here, this is reverse here. Whatever we are doing here, it is a reverse order. Okay. Now if you see, here we are passing linked hash set contains method. Getting the point. But internally we are calling like this. Internally we are calling hs dot contains. Here we are going to pass linked hash set object. Getting the point. But here we are calling linked hash set dot contains, and internally we are calling hash set dot contains. Okay. So this is important. We need to understand here the contains method, how it is working internally. But here we are calling the retains all method. Retains all method internally, it is using the same contains method, and those are the matched records will keep as it is, and unmatched records it is trying to remove from the linked hash set. Okay, this is important here. Now we'll move on to the another important method. Let me go to this particular section because we'll try to discuss about the all the set related method. These are all the set related method we need to discuss here. So we already familiar with this particular add and add all. Now we are discussing about the contains all, and same way we discuss about the contains method. So where is the contains method? Okay, somewhere we added the contains method, and we need to discuss about the remove all. So before going to remove all, we need to discuss about the remove here. So now observe carefully how this remove is going to work internally. Now I'm trying to commenting the all the contains and retain all method. Okay, and LHS dot so remove method. Remove method is expecting object. Now if I'm going to pass this particular 1, 2, 3. If I'm going to pass this particular 1, 2, 3, we need to identify what happens internally. And remove method, what is returning here? It is trying to returning the boolean. Here it is trying to returning the boolean. So if it is returning the boolean, what we can understand? If it is returned true, okay. If it is returns true, we can understand here this object is removed from this particular linked hash set. If it is returning false, the object is not removed here. Now you can see we are getting false here. We are getting false. Now what we can understand here, this object is not removed from this particular linked hash set. So why it is not removed from this particular linked hash set here? So we need to understand because we are providing the 1, 2, 3. Okay, this 1, 2, 3 internally what happens? It is trying to call the map.remove method, and I'm calling map.remove method here. And whenever I'm calling this particular hash map here, so this is the remove node we are calling. Okay, so remove node we are calling. But what we can understand here, we are passing this particular key, like a hash code, and the key we are passing, some object we are passing, some remaining information we are passing. But whenever we are trying to generate hash code and key, we could not find out the node here. Why we could not find out the node here? Because whatever the object I provide 1, 2, 3, So this is the like 1 to 3 object is not available inside this particular linked hash set. So now you can see carefully 1 to 3. This 1 to 3 is no longer available inside this particular linked hash set. Getting the point? Because of this, internally it could not identify the node here. Okay. So we'll debug this particular method. We can understand here how this remove method is working internally. Getting the point? Linked hash set and hash set both are going to do the same, but internally, the linked hash set internally it is going to work based on the linked hash map functionality. Okay, we'll discuss a linked hash map more whenever we are discussing about the hash map here. Sorry, map related example. Now observe carefully. Now I'm moving into the remove internal implementation. I'm calling the remove method. So now you can see we are calling this particular hash here. So it is trying to generate the hash code of this particular key. So after generating this particular hash code key, now I'm calling the remove node. Now you can see what is the hash code 48 to 690. And what is the key we are passing? Something like a 1, 2, 3. And what is the value? Value is null. Okay, because it is trying to load the object based on the hash code and key only. Now you can see, so inside the table only, we are going to inserting all the records here. All the records. Now you can see, these are all the records are inserted. So second index, third index, fifth and sixth, 7, 8, like 12, 15. Okay, 12, 15. These are all the index location. So because it is a node here, node array, not a node, it is a node array. So inside the node array, we are going to insert multiple records here. Okay, now we identified. So it is not equals to null and length also we are having greater than 0. Okay, now it is satisfied this particular condition. Up to this is satisfied. Here we need to check this and whatever the index we are passing here and I am checking here with help of n-1 hash code. This particular section will give you the index location. Okay, this particular section will give you the index location. So now observe, if it is not equals to null, we are trying to set into this particular P and we are entering into this particular like line number 813. Okay, now we'll see. So its conditions, all the conditions are satisfied. And what is the P record we are having here? So here now you can see linked. Here we are getting linked. So why we are getting this particular linked basically? Because based on this particular hash code, getting the point, based on this particular hash code 48 to 690, we identify the index here. So what is the index we are having? 2. Getting the point. What is the index we are having? 2. So inside this particular second index, what is an object is resides here? Something like a linked here. Linked object here. Okay. This is important. So once we identified here, now what we are doing is, now observe carefully. Here we are checking the hash code with the key. Hash code with the key. So this condition will fail. Getting the point? So key is not going to match. So now if I'm going to explain this particular key, what we are having? Here we are having linked. Now here we are checking with the key as a 1, 2, 3. So linked equals to 1, 2, 3. So both the keys are not same. So whenever this condition will fail, it will look over this particular condition. So this condition also will not satisfy. So now we need to move on to this particular section, else if. Getting the point. So now you can see else if it's trying to identify. Observe carefully. So it is coming back to the else if. We are checking here and p dot next. P dot next basically it is null, I hope. Yeah, it is null. Okay. P dot next is null. Whenever p dot next, if it is not equals to null only, it is enter. So this particular section also will failing. Okay, this particular else if also it is failing. So once it is failing, now we need to check about this section, because this is the code. It is what I'm trying to highlight here. This code is implemented inside this particular else if. So what happens internally? If it is not matched, it should be available to this particular if condition. Now you can see. So it is coming back to the if condition. Okay, here we need to check the information how it is working internally. So node, what is the node right now? So node is null, because here this condition is not satisfied here. Because of this, we are making as a node null, and this condition is failing here. So once this particular condition will fail, so here we are checking the AND condition. Now you can see here I'm trying to add one parenthesis. Whenever we are adding this particular parenthesis, so it's going to take highest priority this first. Okay, highest priority this first, and later it is matched with this. Anyway, this condition also will fail. This condition also will fail. Now finally, what we are returning? False, like return null. We are trying to return null. Now observe carefully, whenever we are trying to give this particular, so the record is not available in the linked hash set here. How it is checking here? This is important. How it is checking? First, it is checking with the hash code and the key. If the hash code and key if not matched here, so second, if the node is having any next node, because we discussed internally the hash map, what it will do, whenever we are going to have the same index here, it will try to insert as a next node. But we are checking the next step if it is having any next record. So in this case we don't have any next record. Again we are checking here value related. So value related we are checking. Okay, if this particular value is matched with a node, so it's trying to execute this. But what happening internally? The node, whatever the node we are making, the node is null here. Okay, because of this, finally, it is returning null. So any condition is not satisfied, simply it is returning null. Now, whenever it is returns null, what you need to understand? This the entire section is now it is returning null, so will return as a null. Okay, it will return as a null because here we are using the ternary operator. Okay, so using the ternary operator, and it is trying to return as a this particular value if it is false case. But this condition is satisfied because we are trying to return as a null, so we are going to return as this particular null. Now you can see the remove method, it is trying to return as a null. After returning a null, what we are doing is we are trying to checking with this present. The present basically is not satisfying here. Okay, it is not satisfied this because this section now it is trying to return as a null. Okay, it is trying to return as a null. It is not equals to this particular present here. So finally, it is returning false. Here, what is the operator we are using? Double equals to operator. Just it will compare the value, the right side value with the left side. So right side, what is the value we are getting? Null. Sorry, left side we are getting null, and right side we are having present is a reference variable of object. Okay, this is the reference variable of this particular object class. So both are not matching here. Whenever both are not matching, it will return false. Okay, because of that we are getting as a false. And whenever it is written false, now what happens internally? The object is not removed from this particular linked hash set. Okay, this is important here. So this is the way we need to identify the code, how it is implemented internally. Now we can easily understand how this particular each and every method is going to work internally, and what is the purpose of the each method. Okay, so any questions on this particular remove method? Any questions here? Okay, now if I'm going to pause this 789, now what happens internally? Getting the point. So because this object is available inside this particular linked hash set, so once this object is available, now what we need to identify here? Getting the point. So what we need to identify here? First we need to check about the hash code. Okay, so hash code something like just random number I'm giving. I don't know what is the value. So 64 like 54689, and key we already identified 718. If hash code and key both are satisfied, now what it will do? It will try to remove the node here. If first step is not satisfied, now second step what is doing it? It is trying to identify the node is contain any next node. Getting the point? We implemented internally p dot next here. So p is a node and we are calling the next. If the next node is contain any object here, so the object, the next object we are making as a null. Okay, so whenever we are making this particular null, what happens internally? We are trying to remove the relationship, like we are trying to remove the references information from this particular node array. Getting the point? So this is important. So whenever we are making the second step, the whatever the second object we are having, the object is going to remove from the linked asset. So these are all the two steps are going to perform internally. Getting the point? If I want to remove the object inside this particular linked asset, first step hash code and key it's going to check. If the hash code and key is not matched here, it will try to find out the p dot next. The next node is going to load. If the next node is not equals to null, it will try with remove the operation. If it is not available, simply it will return null. Okay, so this is the code we identified here. So now what happens internally? If I'm going to run this, so it is returning true. Okay, it is returning true. And the first record we are having 789, the first record is no longer available here. Okay, so before calling this particular remove method, if I'm going to print the size will give you the so very clear information. Okay, so before calling the size, like before calling the remove method, what is the size we are having? 9. And after calling the remove method, what is the size we are having? 8. Now what you understand here? Whatever the record we specified here, the record is already available inside the linked asset. Now it is removed here. Getting the point? This is important. And if I'm going to check with another important something like is empty method. LHS dot is empty method. So basically, if it is an empty is nothing but whenever we are trying to call first time, the linked asset is an empty. So at the time it will return like a true. Now it is going to return as a false because it is not an empty. The is empty method now it is returning as a false. So why it is returning as a false? Because the linked asset contains some records here. So it contains some record. Whenever the linked asset, it will not contain any records. At the time, it will return true. For example, so here I'm calling after this particular is empty. I am going to call LHS dot clear method. After calling this particular clear method, now again I'm calling the same is empty method. So like we'll comment out this so that we'll focus on the direct is empty related section. Okay, we can discuss about the is empty related section. Now, first it is returning false, second it is returning true. Why the second one it is returning true? Because we are calling the clear method. The clear method basically it will try to remove all the object from this particular linked asset. Okay, after removing, we are trying to get as a true because right now the linked asset is an empty. Okay, here the line number 27 up to we are having some records here. Whenever we are calling this particular clear method, all the records are removed from the linked asset. Finally, the linked asset is returning as a true because it is having empty records. Okay, these are all the methods we are having inside this particular linked asset. Okay, so any questions? Anyone having any doubt on the specific method? Okay, if you don't have anything, now what I will do, here I'm going to create the one more important example, something like a tree set demo. Okay, so each and every class I'm trying to create as a demo so that we can easily understand what are the implementation. So first I will give you the diagram one more time here. So this is the collection. So collection basically it is a interface and internally it is extended with this particular interfaces. So what is the first interface? List, and the second one is set interface, and third one is queue interface. Okay, so we discuss about these are all the three interfaces, and internally the list is extending array list and linked list. Okay, array list AL and linked list LL I'm trying to provide. And set internally is extending. First one is a hash set and linked hash set. Now we are trying to discuss about the tree set. Okay, these are all the implementation class. So once we completed this particular set, now we'll move on to this particular queue later. But observe carefully how we are having the hierarchy. This is very important here. This hierarchy, if you are understanding it, you can easily understand the collection framework entire, how it is going to work internally. This hierarchy, very important here. Now we discuss about the list related implementation classes. Now we are trying to discuss the hash set. The set related implementation classes hash set is completed, linked hash set is completed. Now we are trying to discuss about the tree set. So after this, we'll move on to the queue related example. Okay, so observe how this particular tree set is going to work internally. Okay, so back to here. Now I'm trying to discuss about this particular tree set. First, I will create the tree set. So tree set is also one of the generic type. Tree set is also one of the generic type here. Now, here I'm going to provide as a double here. Here I'm trying to make as a double. So here I'm making TS and internally tree set I'm trying to create. But if we observe carefully, tree set will contain different constructors here. Tree set will contain different constructors. So observe carefully. This is the default constructor we are having, collection constructor. So second one, and third one you can see comparator. Third one we can go for the comparator. And fourth one now you can see sorted set. Sorted set. Getting the point. So sorted set is one of the interface which is extending from the set interface. So this we discuss in the whenever we are trying to discuss about the interfaces section. Okay, sorted set. So this is the last constructor we are having. Now we'll discuss later this. Now first we'll focus on the these three constructors. Okay, first we'll identify the default constructors. First we'll identify the default constructor and what exactly the default constructor is doing internally. Now let me close all the tabs here. Now open only this collection txt because this is important. The txt file will contain only all the methods here. Okay, now I'm trying to open the tree set default constructor. Okay, now you can see internally what we are doing is this new tree map we are calling. Okay, now observe carefully. So hash set internally it is trying to use the hash map. Okay, and linked hash set. Linked hash set internally linked hash map. Getting the point? Linked hash map it is using and TS. So TS is nothing but tree set internally it is using tree map. Tree map. Getting the point? These are all the internal implementation classes. These three classes we are going to discuss one more time whenever we are trying to discuss about the map related section. Okay, map related section. But observe carefully. But even though these particular implementation classes internally, they are trying to use on these particular classes. So here, the simple example, tree set the default constructor. Now it is calling the tree map default constructor. Okay. Now you can see how this particular tree set is using internally. So this is the tree set, and it is extending from this particular abstract set, and it is trying to use on the navigable set here. Getting the point? It is trying to use on the navigable set here. So how this navigable set is implemented? First collection, and second one is set. Okay, third one is sorted set, and fourth one is navigable set. NS. Getting the point? So this is the interfaces hierarchy. Interfaces hierarchy. Whenever I'm trying to implementing this particular navigable set, so we are indirectly we are implementing this is the hierarchy. Getting the point? Indirectly we are trying to implementing this is the hierarchy. This is the hierarchy for interface hierarchy. These are all the interfaces here. Getting the point? This is important. We need to understand here. Okay, whenever it is implementing, we need to identify this particular method. We need to identify this particular method. We need to identify the specific method which are available, set and collection. So set does not have any specific method. Directly, all the methods are extended into this particular set. The collection methods, now it is extended into this particular collection. Okay, this is important here. So now what we can understand here, all the set related methods we are going to discuss inside this particular tree map. Okay, so we identify the hierarchy. The hierarchy is very important hierarchy we are discussing here. Now, so again, dummy value, because we are trying to work on the hash map. Hash map basically it will store as a key value pair. Getting the point? So key we are going to store with the help of this particular tree set, but value how we are going to store? This is the value. For each and every object we are passing as a this particular present as a value. Getting the point? This is important here. But only we are going to modify the key value. We are going to modify this particular key value. Now you can see now this particular tree set we are not going to call because there is no access specifier here. This is the default access specifier here. We are not going to use outside of this particular package. And this is the default constructor. Okay, this is the default constructor we are having, and it is calling internally tree map. So this is the one more tree set constructor we are having. It is expecting comparator. So we'll see how this particular comparator we can provide and how it is going to work. So this is the one more comparator we are calling inside the tree map. Okay, now you can see collection we are passing. So collection we are passing, and only the current constructor like a default constructor will call, and internally it will call on the add all method. Add all method. Okay, directly it will call on the add all method. So this is the sorted set we are passing, and we are passing sorted set dot comparator, and again we are calling the add all method. And this is the iterator. We are calling on the navigable set and iterator. Okay, so we'll try to discuss about the iterator later here, but focus on the constructors. How many constructors we are having? 4 constructors here. First one is the default one. Second one is expecting collection. Third one is expecting comparator. Fourth one is expecting something like a sorted set. Okay, first we'll focus on the default one, because the remaining 2 constructor we'll discuss later. So observe ts dot add, and here 45.12. Okay, 45.12. Now some 6 or 7 object I am trying to insert in here. So now observe 89.41 and 96 dot something like 74. Some different values I am trying to give. Okay, and observe carefully. So 12.58, and here I'm going to give 123 dot something like 63, and here something like 54.87. These are all the values I'm having. Now, whenever I'm trying to print this particular values, because add method, how it is going to work, internally it will call on the tree map and it will insert the records. But observe, before discussing about the add method, now I'm trying to print these values. Now I'm trying to print this particular values. So observe carefully, what is the first record we inserted? The first record we inserted as a 45. Okay, 45 and 89 we insert at the second. But how we are getting it? So now you can see 12 one is the first, 45, 54, 56. Okay, 89, 96, 1, 2, 3. So how we are getting an order here? Getting the point. So this order is important. Like, so it is something like 0 to 100. So how we are going to insert this particular 0 to 100 values? Same way, the values are printing. So 12. 12 is the smallest value and 1 to 3 is the biggest value. But how we are getting this? Getting the point? But here we are not inserting like this. We are inserting some random values. Like first I've inserted as 45. So last value I'm inserting as a 54. Whenever I'm trying to inserting as a random values, but whenever I'm trying to print, so I'm getting as a like lowest to highest. Getting the point? Smallest to highest, or we can call it as the biggest value. Thus order we are following it. How I'm getting these particular values here. Getting the point? This is the behavior of this particular tree set will contain here. This is the main behavior that tree set will contain. And whatever the linker has it will provide the same order how we are going to insert here. Getting the point? Now we'll see how this order, how it is following this particular order internally. So to understand this particular order, first what we need to do, we need to focus on the add method, how it is calling internally. How this particular add method is calling internally, so that we can easily understand how it is following the the format called lowest to highest. So I'm calling this particular add method. Default, how many values we are going to store? Nothing. It is a empty. So as of now, we don't have any records here. So if I'm going to call is empty method, what we can understand, we are going to get as a true. Because right now we don't have any records inside this particular tree set. Now I'm calling on this particular add method. So now if I'm going to debug the add method internally, first we are calling on this particular double because we provided the double value. After this, now I'm calling on the same add method. So what is the method we are calling? Put method. So what is the M reference is basically here? It is a tree map. Getting the pen. It is a tree map here. Now you can see we are having the reference called tree map. We are calling on the tree map dot put method. Okay. What is the value we are passing? Present. What is the key we are passing? E. And E contain right now. What is the value? So here you can see this particular E contain 45.12. Okay. 45.12. So once it is contain this particular key 45.12, now what we need to understand here? We need to move inside this particular tree map dot put method. Okay, tree map dot put method we need to debug here. So now observe carefully. I'm trying to debug this particular tree map dot put. So observe. So root node we are identifying. Right now it is a null. First we'll identify how this particular root node is defined here. So I'm trying to click on this. Now you can see entry record. Okay, entry record. But where we are defining this? Inside this particular tree map. So what exactly this particular entry will contain here? If I'm going to open this particular class here, now you can see this is the one final class we are having. Getting the point? It is trying to implementing map.entry. So far, we don't know what exactly this particular map.entry will contain. Okay, so don't worry, we'll discuss more about this particular map related section once we complete the collection related here. But observe, just to focus on this particular class, how it is implemented internally. Okay, entry class. Entry class internally is expecting the generic parameter. How many parameters is expecting? Two. First one is key. Second one is value. Getting the point? It is going to work on the key value pair. Okay, now we identified here. And after this, now you can see K we are passing as a key and V we are passing as a value. So now if you see, here we are having different informations. One entry left and one entry is the right and one entry is the parent. So you can see these three classes basically internally we are making the references to this particular class only. Okay, itself the same class itself internally it is making the relation here, but only the differences here left to references like right and parent. But if I'm going to open this, same values will contain here. Okay, same value will contain. This is very important here. This is very important here. The same class only we are providing the type here. Same class only we are providing type here. And so something we are having color block we are trying to initializing here. So after this, now what we are doing here, we are trying to come back to the below statements here. It is a one constructor. This constructor we are not going to call, and now you can see we are passing key value as well as parent and get key. Okay, and get value. And here we are having set value. So equals method, hash code method, and toString method we are having, and this is the first entry. If I want to find out the first entry, this is outside of this entry class. So here only the entry class is completed. Now you can see entry class, whatever I'm highlighting, this is the entry class. But outside of this particular entry class only, we are discussing the first entry. Getting the point? So these are all the nested classes. One of the nested class is something like this particular entry. How we are calling? Because it is a static class. So we are going to call tree map dot entry. Tree map dot entry because of this particular static class here. Getting the point? We discuss about the nested classes whenever we are discussing about the initial class creation. So just go through the video how we discuss about the nested classes so that you can easily understand how we are trying to create this particular final class. But now we identify these are all the properties we are having inside this particular entry class. Okay, we'll come back to this. Now we have identified this entry will contain the key, value, parent, left and right here. These are all the some properties we are having. Now I'll go back to this particular root. So root right now it is a null here. Okay, this is the first record we are inserting. And one more, what we are doing is we are checking the t. If it is a null, we are calling compare method. Okay, we are calling this particular compare method. Now we need to understand this particular compare method, how it is work internally. So I'm trying to debug this. Now observe carefully. What is an object k1 we are passing here? What is an object k1 we are passing? Here we can see double value. So 45 I'm passing k1. And what about this particular k2? K2 also I'm passing same 45. Okay. Object to 19 to object to both are I'm passing as a same value. How I'm passing it? So this is important. Let me go to the same method. Key. Okay. Both keys I'm passing same. Both keys I'm passing same. So okay. Now we'll go back to the same compare method. Now what we need to understand here? What we need to understand here comparator. So right now comparator is null. So far we did not create any comparator. Because of that it is returning as a null. And if it is null, we are going to focus on this. Getting the point? Because this is an expression we are having. If this particular expression is returns true, after the question mark we'll focus. If it is returns false, after the colon, whatever we are defining, we are going to call. So right now the comparator is null. Because of the null, we are trying to work on this particular compare to. Okay, so compare to we are passing. So this particular compare to internally will contain, we already discussed this particular compare to, it will contain the less than, it will contain the greater than, and it will contain the equal here. Okay, so if it is the less than, we'll get as a -1. Here we are going to get +1 because positive values. Here we are going to get negative values, and here we are going to get 0. Getting the point. So whenever we are getting these values positive, negative, and 0, we can understand here this is the less than or this one is the greater than and it is the equal. Both values are same. So compare to method basically it is trying to return as a int value. Now you can see. So int value it is trying to return here. Getting the point. Now if you read this, you can easily understand it will return the negative integer, 0, and positive integers. Okay, it will enter this particular three values whenever they are having less than, equals to, or greater than. Less than, greater than, and equals to here. So this is the compare to here. So now it is trying to come up with here k1, and here also we are trying to pass with the k2. Both values are equal. If the both values are equal, what is the value we are going to get? 0. Now we'll see. So what is the value we are going to get here? Okay. So here now we are not using this particular return value because the compare method. Now if I'm going to compare one more time, so 0. Getting the point? We are getting 0. Why I'm getting this particular 0? Because both values are same. Whenever the both values are same, now this is important here. What we are doing here? We are trying to create a one entry record. One entry record we are creating. Okay, the parent record is null. This is the parent record we are making null, and we are passing key and we are passing value. This value every time is same because only the same object we are going to pass for each and every record. But only what we need to focus on this particular key. This key only it will modify here. Okay, what is the key we are passing here? Something like 45.12. Value something like a present. Value we are passing as a present. So the parent record we are trying to inserting as a null. Okay, this is we need to understand this particular entry record. And after this, what we need to understand here, we are trying to set as a root record. So this is the root record we are setting here. After this, we are increasing the size and mod count, and we are trying to return as a null. And if it is null, if this particular put method it is returns null, we are going to return as a true. Okay, the add method is finally returning null. So one more time I am calling the same add method. So we'll focus on the one more time. So we'll go back to the double, and we'll come back to the same add method. Now I'm checking. So again I'm calling the same put method. Now, so right now the root is not null. Right now root is not null here. Now you can say root is having some double value, something like a 45, and the value we are making as a object. Okay, so we are not going to compare. We are not comparing this. Now, what happens internally whenever we are not comparing this? So this is the internal code we implemented. Getting the point? This is the internal code we implemented whenever this particular t is matched here. Okay, the t is matched. Right now, this t is not null. Whenever it is not null, we are trying to find out this particular comparator. So the comparator is null. CPR is null. So carefully observe, if the CPR is null, so this particular block will fail. So we need to focus on the line number 559. 559 we need to focus here. Now you can see key is null. No, key is not a null. We are providing 89.41. So key is a not null value. Now what I am doing here? So if the comparator we are not providing, so by default it is signed to use on the comparable. Okay, it's fine to use on the comparable. We'll discuss about these two information. Both are interfaces here. We'll identify how these particular interfaces are implemented internally. Okay, and now you can see what I'm doing. I'm trying to converting this particular key as a k value. Whatever the key we are having, I'm trying to converting into this particular k. Now you can see what happening internally this particular k. What happened this particular k? If you see, same value, whatever the value we are having, 89.41. But internally I am trying to converting into this particular comparable. So we are using do while loop. So observe carefully, here we are implementing the do while loop. So do while loop basically it will execute the first time. Getting the point? It will execute this particular section as the first time. If it is matched this particular t, it will repeat the second time also. Okay, if the t is not equals to null, it will match with the second time. Otherwise, it will come out of the do while loop. Now observe, whatever the t, basically t is a root node. So this is the first record we created. The parent will be null. Now the parent we are making as a null, and this is the parent record, because parent record every time the parent record will be only one, and the parent cannot have a one more parent here. Parent cannot have a one more parent. Because of that, it is returning as a null. Okay, so simply we identified, and now you can see here we are calling k dot compare to t dot key. Here we are comparing. So k value right now how much here? Something like 89. Something like 89. And t dot key how much we are having? Something like 45. Getting the point? Something like 45. So compare to method. So compare to method, as I explained here, it will try to check on the less than, greater than, and equal. It will return the value. So based on these particular values, if it is return the positive value, we can understand it is the greater value. It is returning minus values, so that we can understand less than values. Okay, if it is returning 0, we can understand it is a equal values. Now we'll see how this particular compare to method is implemented internally. Now I'm moving inside this particular compare to. So observe. So what is the compare to method is calling? So it is moving on to the double class. Okay, the double class compare to method is called. Now you can see. So what is the CMP we are getting here? The CMP we are getting as a 1. So it is a positive value. Getting the point? It is a positive value. Whenever we are having positive value, what we can understand here, it is a greater than value. Okay, so what is the key we are having? 89, and t dot key what we are having? Something like 45. So 89 is a bigger value. Getting the point? So 89 is a something like some highest value. So if we are checking here, so CMP it is not less than 0. So now we are checking it is a greater than 0. Now whenever it is greater than 0, we are inserting t dot right here. T dot right. So right now, t dot right now, what is the t dot right value we are having? It is a empty record. Empty record. Okay, it is a null record because this is a second record we are inserting. Right. So far we don't have any left and right records. So just we are having only one parent record here. Okay. So else if is satisfied, but even though the t is null, and if the t is null, so this while condition is failing. Getting the point? The while condition is failing, and finally we are coming out of this particular do while. Now I'm trying to create a one more record here. So observe carefully. We are trying to create a one more entry record, and here I'm passing parent. Here I'm passing parent record here. Okay. So this is the parent record. So what is the parent record we are having? The 45 value whatever we provided, the 45 value is the parent record for this particular 89. What about the 49, 45 it is having any parent here? No, parent here it is null. Okay. For 89 we are having a parent is 45. Getting the point? So this is the important information we need to understand whenever we are trying to create this particular entry record. So finally we created this particular E. Now the key value 89. Getting the point? Key value 89 we are having. So for example, if I'm going to pass parent E dot parent, we'll get as a 45. Let me try that so that we can easily understand. Now here E dot now you can see what happening internally. So inside the expression, so I'm trying to add p dot parent here. So the key value we are getting as a 45. Now what you understand here? If I'm going to print here only E. If I'm going to print here only E, now observe what is the key we are having? 89, and this particular key contains 45. Now what you understand? Here you can see like it is something showing as a very small here, but I hope you are able to see E dot parent. E dot parent. E is the current object and I'm calling the parent. So it's containing the 45 and E is the current object. I'm trying to print 89. Okay. This is the hierarchy we are going to follow internally. Now CMP again we are checking here. CMP basically it is a right condition will satisfied here. Parent dot right. Okay. Parent dot right we are making is this particular E. So carefully observe how we are initializing this information. So two records we created. One is a parent record and another one is a one child record we created. And the child record I'm trying to set into parent right here. Okay. Parent right. So anyway, we are trying to so fix after insertion. So what we are doing is, so now you can see these are all the some information we are having. Now you can see these are all the some bigger code we are implemented here. With help of this particular while loop, it is going to provide the position here. Okay. Now we'll see the X color. Whatever the X color we are having, we are making as a red here. Now we are checking the while condition. So it is not satisfied the while condition. Now finally, we are trying to make as a block here. Okay, size plus plus mod count, and we are trying to returning null. It's matching here. So second add method we call. Now we are moving into the third add method. Now we'll see how this particular third add method, how it is going to work internally. So again I'm calling put method. So what is the root we are having? A root is a something like a 45 one. Okay. So this is the root one. So we are getting the root one. Now we can see so the T condition is not satisfied. Comparator we are checking. Comparator also it is not going to satisfy. So we are checking the key. It is not null. We are trying to converting into the comparable. We are trying to load this parent. Again this parent will have only the same 45 with. And again we are checking K. Okay. So what is the K right now? something like 96, I hope. 96, yeah, 96.74. So here we are checking 96 dot, we are checking with the 45. Again, this particular CMP, we are going to get some greater than value. Now, what is the value I'm getting CMP? So, what is the value I'm getting this particular CMP? Here you can see 1 I'm getting, because 96 is a greater value. So, again, we are going to check this. So, this is matching here. Now, you can see T dot right. So, T dot right also we are having some records here. Some record. So, it is a, okay, T dot right also we are having. I'm trying to identify something like 89 record we stored in the right object here. So now T dot, so basically T is a not null. One more time, this particular loop will repeat. So right now the parent is going to replace here. Earlier the parent we are having 45. Now the parent is going to replace it with 89. If I'm going to show you the parent, now we'll get as a 89. Okay. So why we are replacing it? Because here we are trying to initializing the t value, and if the t is not equals to null, the while loop it is going to repeat one more time. This is very important, the do while loop here. Okay, this is the very important information we are discussing this particular while loop. So finally, what I'm doing is I'm trying to identify this particular do while here. Okay, so anyway, now we are identifying this. So we are trying to repeating one more time. So what is the CMP we are getting here? CMP, again we are getting 1 year. So when we are getting the 1, when we are getting this particular 1, so again this will satisfy, but right now we don't have any right side value. So the t will be null. The t will be null here. Okay, the loop is going to stop here. The while loop is going to stop. We'll come out of the, okay, we'll come out of this particular do while. And finally, now what I'm doing here, so again we are trying to create this particular record. This is important here. Parent is modified here. Getting the point? Parent is modified here. Parent we are setting as a 89. For the 89 record, parent is 45. Getting the point? So now for this particular 96 here, we are making as a 89 as a parent here. So this is the way of creating the entry records here. Now, what is the parent we are having right now? 89. For this particular 89, we are trying to set as a right the 96 whatever we created. Whatever we created 96, now it is setting as a right record. Okay, this is the way of working internally. Okay, so right now, so if we observe carefully, we are trying to make the insertion order, like, sorry, not insertion order, the like lowest to highest, how we are converting. This is the method. Getting the point? This is the method. The line number 566, whatever we defined here, this method is going to provide the lowest value and highest value. Getting the point? This will take a very important role inside this particular tree map. So finally, third record we inserted. Now we are moving. So 96. Now we are checking with 56 here. So we'll see how this particular 56 is going to work internally. Now again I'm calling the put method. Now I'm checking the root one. What is the root? Root basically is the 45. Okay, now it is replaced here. So where it is replaced here? Now the root is replaced with okay, got it. So in the previous example we replaced now root is modified to 89 here. Get in the point. So root is modified. Now we are checking the comparator. Comparator null. Key is not null. We are converting comparable. Okay. So key value. So key value is 56 and t dot key. It is a 89. So 89. Get in the point. This is important. Now you can see. Now you can see. This is a 89 value and this is the 56. So we'll get something like a less value. Now you can see -1 we are getting. Getting the point? Because 89 is a bigger value compared to this particular 56 here. So here we are getting -1. Whenever we are getting -1, now we are satisfying this particular condition. So t dot left. So right now we don't have any t dot left. T is a null. We are coming out. So t dot left we are already identified object here. So 45. Okay. So we stored here the 45 record here. Now you can see 45 record we identified here. Now whenever we identify this particular 45, second time we are trying to store. So now t dot to t dot key, it is written as a 45 and we are having this particular 56. So 56. Now you can see not matching. So this one will match and the right side value. Now you can see right side value we don't have for this particular 45. Now we are creating one and we are trying to inserting. What is the parent here? What is the parent? 45. Getting the point. So again we are trying to get this particular parent. Parent dot right. If I'm going to add one more expression here, we can identify here. Parent dot right. We'll see any value will get here. Now parent dot right. So here you can see null. Parent dot right we are having null. Now we are trying to replacing with this particular e. What is the e will contain here? Something like a 56 here. Getting the point. So this is important. If you are trying to work multiple times, then only we can easily understand how this particular tree map will work internally. Tree map, how it is working based on this particular entry records. Okay.
Hello.
Yes.
Sir, like here we are at the do while loop, like we are mentioning that left condition, we are comparing the left and right condition, comparing greater than 0 or less than 0. So actually we given in the variables uh, in the class we given in a random order, like
Okay.
and you said like we will get in the smallest value to the higher value at the output. So while it is considering, so how it goes through from the left to right, like while uh, in that the while in the do while loop.
Same thing, because if you see random value, if you are going to get something like this is the random value, so 10,000 something 200 I'm having. Now if you try to compare with this particular 78, so which is the bigger value? This is only the bigger value,
Yes.
right? If it is the bigger value, now definitely it will go to the greater than only. It will get as a positive values, like we may get 1 or 2 something 3 anything, but it is a greater than 0. For example, same random value if I'm going to get something like minus 10,800. Now what happens if I'm going to compare with the same 89? We'll get the minus values here, like minus 1, minus 2, something like minus 3. These values are less than only. Here only it is showing the less than values. But here, this value is going to return by the method, whatever I discussed, compare to method. So instead of written explicitly, we are calling the one method. The method will return the value.
Okay.
If I'm going to provide the same method where we have not this entry set, yeah, here now you can see, for example, t dot key. So the t dot key, as I explained here, so we are going to get 78 and k value. So because we are trying to compare with this particular value, k value if you get as a 68. Now what I'm doing is I'm trying to compare with the 68 to, so just I'm trying to compare with these two values. So which one is the biggest value? 78. Whenever it is 78, we are going to make as a something like this. 68 less than, sorry, 78. Okay, 68 less than 78. So in that
Okay.
case, the compare to method, because compare to it is trying to return the integer value. Let me show you anywhere we have a implementation, so that you can easily understand how it is implemented internally. So it's taking some time. Okay, we'll move on to it is a final class. Inside the double we have, okay, we are calling the double. Which one is the better one? So final classes we cannot identify. Okay, so I will only create this comparator later. We'll discuss this particular example. Now observe. I will stop this because this comparator is implemented more example. Like more the classes is implemented this compared to. But simply understand this. If I am trying to providing the bigger value and this value is like a smaller value, definitely this value is only the bigger so that it will return the positive or negative value. But here, if you provide the bigger value first parameter, okay, see carefully. So 98, and here I'm trying to provide 78. In this case, we will get as a greater than value 1, 2, 3 something. And here, if I'm trying to providing 65, even you are going to provide the 78. 78 is a bigger value compared to this particular 65. But anyway, we'll get the less than values. Why we are getting the less than value here? First, we are comparing with this. Okay, we are comparing with this. Because of this, it is a bigger value even though we are trying to return. This is the smaller value. So just we discuss here, one condition is satisfied with the left condition. Okay, this is important here. Because of that, we are getting the -1. So because of that, it satisfied the left one. Even you can take any value, not only this particular value. You can call the random, the method which we discuss in the random class. You can pass the random values. Not a problem. It will discuss. It will return only -1, 1 or 0. So 1 maybe it's going to modify with 1 to 3 up to 100 something, and the same -2, -3 also we are going to get. Whenever we are getting the minus value, it is a less than to 0.
But in JVM, in the like in I think in JVM the negative values will not be will displayed as a output, right? Sir?
We are not moving into any, just it is a simple expression like with simple logic we implemented
Okay,
for
okay,
understanding the left side or right side the entry record here. So this is not related to any JVM here.
okay.
Okay, basically using this comparative we are identifying whether do we have any left record or right record. If we don't have, we are going to insert here. So basically we are comparing with the bigger value with the left like a smaller value, so that only we are going to get order, the smallest to highest order, how we are getting the same order. If you see
Okay.
here, as of now we are getting like as of now whatever we inserted, we are getting some order here. If you observe carefully, first one we inserted as a 45, later 52 or 56 we are having, and later something like 82, and finally 96. So this is the order it is followed, but how we are creating the order we are trying to create with help of this particular left and right here, left and right
Okay.
here. So far how
So
many records we inserted here? This we are calling with help of this particular code. This is the code is going to play very important role in the tree map here.
so for if when it comes to string, how then how we can
So string is different. This particular code we are going to use in the like Java core Java only, not in Spring. If you write any class in the Spring, definitely we are going to implement the comparator or comparable, because these two are the interfaces. So in the Spring also we are define the same how we are defining this particular tree map. Same way we are going to create a classes and we'll implement. And if we observe this particular tree map, if I'm going to show you the class level navigable map we are having, and it is not showing this, and internally we are having comparable. So here we are having the comparator. So it is trying to declare as a variable because the type we are having as a comparator. Okay. So instead of implementing this, they are trying to take as a it's like a something like a parameter, like variable, how we are defining into double. Same way it is defining something like you can see how we are defining the int size. Same way they are trying to defining as a comparator. But this purpose is different and this purpose is different here. Okay, so one class we'll discuss here by implementing this particular comparator so that we can understand how this particular the tree map and tree set is going to work here. Now you can see we'll come back to it first to understand how this add method is working internally and how we are getting the order here, like smallest to highest how we are getting. This is first we need to understand. Later we can create a custom class and we can implement the whatever the expected way we are expecting here. Okay, so back to here. Right now we are moving into the 56. Now 56 is moved to the which position? Second position. First we put as a 45. Now second this 56 put it. Like third one 89, fourth one is 96. So order as of now this is an order. So far the order inserted 45, 56 and 89 and finally 96 here. Now we are trying to inserting 12. So this particular 12, if you observe carefully, so it will going to store as a first record. We'll see how it is going to store as a first record. Now I'm calling the same method here, add method I'm calling, and here we are trying to pass this particular 12 value. Again I'm trying to move inside this. So what is the key we are passing? 12. And now if you see the what is the root we are having? Something like 89. Okay, this root now it is containing the left and right here. Getting the point? So let me clear all the expressions here. Now here I'm going to add one more. Here I will add something like root dot. If I'm going to call root is the entry one, right? If I'm going to call root dot right here. Now you can see what is the right value we are having? 96 here. Getting the point? Root is having 96 right side value. Okay, I'm going to add this expression. Let me see anything. Otherwise here I'm going to write left. Okay, I'm trying to add left here. Now 45 we are having left. So carefully observe. So 89 is the root. Left side we are having 45 and right side we are having 96. And 89 will contain any parent. Now we need to understand here. Now I'm trying to write this. So root dot parent here. Okay, root dot parent. Right now parent is null. Getting the point? So where is a 45? Getting the point? Where is the 45 here? Because we inserted 4 records so far. But how many records we are able to see? Only 3 records. Now we need to identify the 45 also. Getting the point? Now this is important here. Now if you see, we'll identify first left here. Root dot left dot, and if the left will contain any parent, this is important here. So parent we are having for this particular left record parent is 89. Okay, and parent is not away, and I'm going to call right. Now you can see 56. Now what you understand here, this 45 internally again having the right side value. Again it is having the right value, something like 56 here. So far how we are inserting, this is the root we are having. Okay, this is the root. So right side we are having 96 and left side we are having 45, and internally the 45 again internally it is containing right side value something like 56. So if I'm going to show you for this particular left side value, if I'm going to make one more left will be null. Okay, left will be null. Getting the point? So this is important here. So only right side we are having. What about this particular right side value? Root dot right dot and one more right I am calling. The right we are making as a null. And if I'm going to get only right here, if I'm trying to print only right here, 96 we are getting. So see, so carefully observe this expression. Carefully observe this particular expressions here. I'm trying to show you the what all the values so far we initialized here. Okay, so root the right side value right now cannot have right side value, null we are having, and the same way this left side also we are going to have null only. Okay, these two are still null. Okay, this is the root here. For 96, what is the parent here? This is the parent. Okay, 45 also we are having the parent 89. So observe 89 is now is playing the important role. Now this is the parent record. So for the 89 we don't have any parent because parent cannot have any one more parent. Okay, this is important, we need to understand here. So observe carefully I am going back to this, so I will try to write the diagram one more time. Smallest diagram I'm trying to write here. Now, here you can see 89, right side we are having 96, left side we are having 45, and here I'm having something like 52 or something 54, something we have. Okay, so far we inserted these values. Now we'll identify the 12 record how it is inserting. Okay, root is 89, the T is also 89. Okay, so key not null. Now we are trying to converting. What is this particular T? Okay, T dot key. What is the value we are going to get here? 89 will get. Now you can see 89 we are getting. And what is this particular K? What is this particular K? So whatever the value we are inserting this. So that is called 12. Now you can see 12 we are comparing with 89. Now we'll see what is the value we are getting. CMP, it is a -1 because so 89 is the bigger value, the 12 value is a smaller value. Okay. Now what happening internally? This is important. We are getting -1. Okay, whenever we are getting the -1, which condition is satisfying? The left condition is satisfying. So now if you see T dot left, what is the T dot left we are having? T dot left we are going to load as a 45. Okay, now observe carefully. Whenever I'm trying to load this, now if you see this T, now it is going to provide as a 45. So whatever the diagram we created, expected result we are getting. After 45, this condition is satisfying because T is not a null. Now this loop is going to repeat one more time. Now we are, so this is the parent. Earlier 89 is the parent. Now the 45 is the parent. Okay. Now 45 is the parent. Now the root also modifying here. Getting the point. Whatever the root record we created, the root also now it is going to modify. Observe carefully compared to we are calling. So T dot key. Here we are going to load as a 45. Okay. So 45 we are loading, but this particular K value will be same. K value will be same. That is called 12. Now again, if I'm going to run, again we are going to get as a minus value. It's like a negative value only we are going to get. So again we are getting -1. Okay, earlier we checked with 89, we got the -1. Now we are checking with the 45, still we are getting the -1. After this, again I'm trying to load this. So far, for this particular 45, we don't have any left record. Only we are having right record, left record we don't have. So it is null here. It is null. So the t value we are going to get as a null. Now if I am going to expand this, the t value here you can see we are getting as a null. So if you are not interested, you can go to the variable section. You can see the t value null here. So this particular loop, it is stopping here. This particular loop it is stopping. Why? If the t value not null only, the loop is going to repeat one more time. Okay. So that loop is stopped here. Now again we are creating one record. So what is the parent now? Parent 89 not a parent. 45 is the parent. Okay, 45. So what is the record we are creating? 12 record. Okay, so 12 entry we are trying to create here. So we created the 12 entry and CMP right now -1. CMP right now -1. Now again we are trying to store. What is the parent here? 45. Now it is trying to insert as the left record. So it will replace this particular null 12. Okay, it will replace this particular null with a 12. Now observe here. Getting the point. This is important here. So what is the parent now? If I'm going to show you the root here. So this particular root also now modified here. So still the root is not modified here, but anyway, because here T, this particular T we are using the parent, and we are using the same. It should be replaced here because we are working on the object references. So parent dot right, parent dot left we are updating it. Now finally we are moving size plus mod count. Okay, we are returning null. So this is the simple example is created 12. Now if I'm going to show you the 123 how it is going to work. So this is the one more time we'll discuss this particular double add method I'm calling. So put method I'm calling and root here. So what is the root we are having? Now you can see still it is in the 18.9. Okay. So maybe now it will going to modify here. So you can see T. So T value, again we are having 89. So the same diagram it is going to look like here. Okay. And so comparator not matching, CPR not matching, key is not matching. Okay, comparable. So parent 2. So what is the parent right now? What is the parent right now? Same thing like 89. Again we are coming back to the from here. Now it is playing the parent role. Later it will parent role is the difference. So we'll see what is the parent role. Okay. Now back to here. T dot key 89, K value 123. Now we'll get as a positive values. Now you can see 1 I'm getting. It is a positive value. So this condition is not satisfying. This condition will satisfy. So right side value I'm loading. Right side value. Now I'm trying to load this particular 96 here. This particular 96 I'm trying to load. After loading this 96, now if you see, the T will contain the 96 here. Okay. So one more time this particular loop is going to repeat. So now you can see. So what is the parent now? So parent now it is moved to the 96 here. Okay. Not this parent. Now it is moved to the parent is this. So after this 123 dot 96. Again we'll get as a positive values. Now you can see CMP we are getting positive value. So for this particular parent we don't have any write record here. We don't have any write record. So this particular T will be null. The T will be null here. Now, so this particular T it is going to match it here. So what is the parent right now? 96. What is the parent right now? 96. For this particular 96, the right side value we are trying to store as a 123. And what about this particular left side value? Still it is a null. Okay. So if we observe, we are trying to create a record, entry record. We are trying to pass as a parent. The parent we are having 96. And what is the key we are having? 123. Now we are trying to creating this. And we are trying to set parent dot write E. Okay, this is setting. And after this, we are trying to calling this particular fixed insertion and size method, mod count. Okay, and returning null. Finally, which method we are calling? The same add method. The last record we are calling 54. 54 we are calling. Okay, so I'm calling this same add method, and now you can see put method we are calling, and we'll see the root same thing. I hope 89. Yeah, it is a same 89, and we'll see comparator, CPR, and key, and comparable. Okay, parent as of now it is a 89. So 89, 89 we are trying to check with 52 or 54, something 54. Okay, so this will give you the less value, like it is a negative value we are going to get. Now you can see negative value. So we are loading left side. Whenever I'm trying to load left side, we are trying to load the 45. Okay, 45 we are loading. Now observe 45. So 45 here you can see this, the T 45 we are loading. Now one more time it is going to repeat here. The 45 is now is the parent. Okay, and 45 with 52. So we are going to get positive values. We are going to get positive values. Okay, once we get these positive values, we are trying to load the right side value. So we are going to load 52. Okay, because the right side value we are having 52 and left side we are having 12. Now we are trying to load the 52. Again this particular loop is going to repeat. Now what is the parent right now? 52. So this value will give as a negative value. CMP now you can see we are getting -1, and 52 is the parent now. 52 is the parent now. The 52 internally is going to have left and right. It is going to have left and right. We'll see. So left condition is satisfying. Left we don't have any record so far. So T is null. We are checking. So what is the parent we are having right now? 56. Sorry, I need to modify this. 56 here. So what is the key we are inserting? 54. Where it is going to insert here? In the left section. In the left section, which is going to insert 54. In the right section, we are inserting null. Okay, this is important. So CMP is not a null. Parent we are inserting as a left here. Parent we are having 56. The left we are initializing with this particular E. Something like the E we are having right now 54 here. Okay, this is the parent dot left we are inserting. After this, we are increasing the size mod count. So far, we insert all the values, but whenever I'm trying to call this particular println, the toString how it is implemented here. Okay, toString how it is implemented, this is important. Now what we can do, we'll move on to the whether do we have any toString or not. So now you can see we don't have a toString. We'll go to the uh, what is the class we are having. Treeset is does not have, and if it is not having, we'll go to the abstract set here. Whether do we have? So here also we don't have. Now I will go to the abstract collection, and here we are having toString method. Now I'm going to put a breakpoint here. The line number 465, I'm putting a breakpoint, and we'll come back to here. I'm calling this. The toString is calling here. So it is available inside the abstract collection. So we are calling the iterator. Okay, has next to now string builder is appending with this. Now we are calling the next here. So which next is going to call? This is important here. Okay, so far which next it is calling, this is the method we need to discuss here. So if I want to discuss this, we need to identify the iterator first, where this iterator is implemented. Now if I'm going to provide this, abstract collection is moving. Okay, so where is this? Here only I will call ts dot iterator. If I'm going to call this particular ts dot iterator, now it is calling navigable set. So this is the navigable set iterator it is calling internally. Now this iterator will call here. Where it is implemented in the tree map, this is the navigable set. Okay, key set only. If it is key set, okay. Navigable set, I want to implement this. Okay, so most probably this is the iterator is going to call, and where we have a next method, size method, map dot entry, clear method, remove method, subset method, headset method, subset headset tail. Okay, where is our next method we have? Navigable key iterator, get first entry, lost entry. Okay, so far I think right now we don't have a next method. Now what I will do here, first record I'm ignoring. For the second record we'll call the next method. Now you can see if I'm going to show you this particular SB, it is containing 12.58. This is important how it is load this particular 12.58 here. So I want to show you this, but so we are having very whatever the time we specified, the time we crossed here. But one iteration I will show you. Later we continue on the evening session here. Now you can see we're calling next entry. Okay, next entry. Next entry, I'm going to expand this. So this is the next entry. Now we are having the next record. And what is the next record we are having? 45. How I'm going to get this particular next record here? This is where we initialize this particular next here. We need to identify private entry iterator. Okay, private entry iterator we are having, and here we are having this constructor. It is calling internally. This constructor only it is trying to returning the each and every record next. So here we are getting the next record that is called 45. The 45 we are printing, but whatever the diagram we are having right now, this diagram only it is going to play important role to load the all the object. If you see here we are using the same entry record. Okay, here we are using the same entry record here. We'll debug the code. So one more time, we'll see. I will define this particular diagram one more time, and we'll debug the how this particular toString method is going to call internally. Okay, the toString only will give you the all the information. So these are all the lowest to highest we are getting because of the compare to method. Okay, because of the particular compare to method, we are trying to get the lowest to highest. And finally, We'll create a one custom comparator. We'll identify how we can write the sorting logic here. Based on that, it will try to sort our values here. Okay, so tree set is very important example, and if you understand this particular tree set, we can easily understand the tree map, how it is going to work internally. Okay, so if you are having any questions, so we can discuss in the evening session. Again, I'm going to create this particular diagram. We'll continue the same example with the different methods what we have inside this particular tree set here. Okay, I will continue evening. If you are having any questions, we can discuss in the evening sessions here. Okay, we'll continue on the same session in the evening.